Applications of rational equations. For this example, Tom can paint the deck in 8 hours. If Craig helps him, they can paint the deck in 5 hours. How many hours does it take Craig to paint the deck alone? Express your answer as a fraction reduced to lowest term if needed. This is about the work problem. Let's make a list of what we know and what we don't know, what we are looking for. The problem asked for how many hours does it take Craig to paint the deck alone. From the information provided, so I'm going to put as a given information here. Tom can paint the deck in 8 hours. So that means he takes 8 hours to get the job done. So one task or one work done. And then, or the job done. The problem asks for how many hours does it take Craig to paint the deck alone. For Craig, gonna be X hours, which the number that we are looking for to get the task done or get the job done. That means alone, Tom takes 8 hours. Alone, Craig would take X hours. And then another information that we have here, they can paint the deck together in or finish it in 5 hours. So we put the note over here, like together. Takes 5 hours to get the job done. So we're gonna break it up as for Tom, that means in 1 hour. For 1 hour, what portion of the work that he can get it done? Gonna be 1/8 portion of the work. For Craig, gonna be 1/x portion of the work done. And together, gonna be 1/5 of the job done. With this information, we're gonna set up the equation by putting the note over here as Tom together with the Craig individually and then work together. The portion of the work as Tom can get done would be 1/8. For the Craig would be 1/x. Together would be 1/5. So this is the portion that work in 1 hour. And then at this step, we get the equation in the rational form, or it's called rational equation. To solve for x, look for the exponent solution. So exponent solution is, we know that x cannot be 0. Exponent solution, or the number that we excluded. So we put it x cannot be 0. And then look for the LCD, or the least common denominator of 8 and x and 5. They're going to be 8 multiplied by x multiplied by 5, or 40x. We're going to solve for x. So put a note over here on the side. The next we're going to solve for x. And then multiply all the terms with the LCD, or the least common denominator, which is 40x. And cancel out. So 8 goes to 40. X would be 5 times x. And then x and x reduce. 5 go to 40, like 8 times. Going to leave 8x for the last term. Now we get 5x plus 40 equals 8 times x. Subtract 5 both sides. So 5x, sorry. Now we get 40 equals 3x. Divide both sides by 3. Therefore, we get x equals 40/3, or 40/3 hours for Craig to work alone. In this example, one host can fill a swimming pool in 12 hours. The owner buys a second host that can fill the pool at twice the rate of the first one. If both hoses are used together, how long does it take to fill the pool? Let's make a list of the known information or the given information. For the first host, it takes 12 hours to fill the pool. So get the job done or one job done. And then the second host, this is, can fill the pool at twice the rate. So that means faster. So cut back the time in half. It's going to be takes 6 hours to get the job done. The question asks, if they are used together, how long does it take to fill the pool? So together or both hoses together. X hours, that's the number that we are looking for, will get the job done. And then we look at the portion of the job that can be done in 1 hour. So that means in 1 hour, the portion of the job done will be 1/12 for the first host. For the second host, going to be 1/6 of the job done, and together going to be 1/x. Set up the equation or the rational equation would be the in 1 hour. So the portion of the job that is done the first host plus the second host should be the same as working together. The first host would give us 1/12 portion of the work done. The second one would be 1/6. Together would be 1/x. So now we get the equation or the rational equations represent this problem. The extraneous solution would be the terms x cannot be 0. Or x equals 0 is the extraneous solution. So we exclude x0 from the solution for this problem. And the LCD would be the product of 12, the greatest common denominator of 12, 6, and x. For 12, 6, and x would be 12 times x. So multiply all by 12x. So 1/12 plus 1/6 equals 1/x, and then multiply by 12x, 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 12 and 12 reduced, 6 and 12 reduced to be 2, and then leave x there, x and x reduced. Then we get x plus 2x equals 12, or 3x equals 12 gives us x equals 4 as the number of the hours that both hoses are used together to fill up the swimming pool.